So, welcome to the next session of the scattering matrix parameter concepts. Here we will investigate the scattering parameters of a two port junction. So, consider a two port network. We now specialize from the n port network to the two port network. So, consider a two port network. Here is S21, S12. Okay. So, this is the general depiction of the two port network. So, what do we have? We simply can write down the equation involving the voltage waves, the incident and the scattered voltage waves. So, from here so these two equations, they are the magnified or the explicit form of this equation for the two port network. Now, if port 2 is terminated in a matched load, if port 2 is matched, V 2 plus will be equal to 0, straightforward. So, S11 is the reflection coefficient at port 1 with port 2 matched, because S11 will be V 1 minus by V 1 plus with V 2 plus equal to 0. Similarly, S21 is the transmission from port 2 to port 1. Sorry, S21 is the transmission from port 1 to port 2, V 2 minus by V 1 plus with V 2 plus equal to 0. Now, if a normalized impedance Z2 bar is placed at T2, if it is placed at T2, if a normalized impedance Z2 bar is placed at T2, therefore, there will be reflection at port 2, there will be reflection from port 2. Therefore, we can write under this condition straightforward, where gamma L is the reflection coefficient at the load. So, I can characterize the reflection at the port 2 by this reflection coefficient due to this load normalized load impedance Z2 bar. So, if I substitute 13 to 12, if I substitute 13 to 12, we will get and that will be equal to S12 gamma L V 2 minus, let us call this one. And from 12B which is this equation, from 12B we can get call this 2 . So, which will mean V 2 minus is minus S 2 1 . So, we call this 3. So, now solving for V 1 minus by V 1 plus, okay. Solving for V 1 minus by V 1 plus, we get just substitute this equation in here. So, you replace V 2 minus by this term. So, we will get a relationship involving V 1 minus and V 1 plus, and then we will get if we just do just simple algebra. So, we call this equation 14. So, this gives the reflection coefficient at port 1 when port 2 is not match terminated, that is we have a gamma L at port 2. So, it gives the reflection coefficient at port 1 with port 2 not match terminated. Now, for a reciprocal junction, or a reciprocal network, S12 equal to S21. So, there are 6 independent parameters in the network, and what are they? S11, S22, S12 both their magnitude and phase. So, for each of these we will have their magnitude and phase, and therefore, there are 6 independent parameters. There are 6 independent parameters. If in addition the junction is lossless, we will have 3 parameters, 3 independent parameters. How? Let us see. So, for the lossless junction, we can invoke the conditions in equations 5 and 10, which we discussed before. We can apply them for the 2 port network, and let us see where we come to after we apply those conditions. The first is S11 S11 star plus S21 S21 star is 1. The second is S12 S12 star is 1, and the third becomes so we call this 15A, this 15B, call this 15C. So, these are the 3 conditions. So, since the junction is reciprocal, we can write 15A, 15A we can just replace S21 by S12 we do not need S21 because the junction is reciprocal. We call this 16A. And 15C can be written as we call this 16B. We just replace S21 by S12 because of the reciprocity, the junction is reciprocal, the reciprocity of the junction. So, now if you compare 16A and 15B, (16A) and 15B, what do we get? We get mod S11 square equal to mod S22 square, because these two terms are the same. So, that is from 16A and 15B. And therefore, that implies mod S11 equal to mod S22. So, we call this (70). So, what does it mean? The reflection coefficients at port 1 and port 2, the reflection coefficients at port 1 and port 2 are the same for the lossless junction. But what about their phases? What about their phases? To investigate that, let us go to the next part. But before that, from 16A we can also write so, we can write that the relationship between S12 and S11, and therefore, we can restate this as S12 is root of 1 minus mod S11 square. Now, as we were saying that how are their phases related? So, for that let us assume let S11 be given by mod S11 e to the power theta 1 e to the power j theta 1. And S22 equal to but because S11 and S22 their magnitudes are the same, we can write this as mod S11 we can write this as mod S11 e to the power j theta 2. Regarding S12, we can write mod S12 e to the power j phi. And replacing from here in terms of mod S11, so we can write this as root of 1 minus mod S11 square e to the power j phi. Let us call this equation number 18. Now, from 16b, if I look at equation 16b, which is here, so I can write that 16b read S11 S12 star this was the statement of equation 16b. Now, we do substitutions, we just substitute their magnitude and phases. So, S11 is mod S11 e to the power j theta 1, S12 star so it is mod S12 e to the power minus j phi. Then we again have S12 e to the power j phi, and then because S11 is the same as S mod S11 is the same as mod S22, I can write S22 star as S11 e to the power minus j theta 2. That will be equal to 0. And then we can take these two terms common. So, we can write So, we can write this, or we can write then just replacing S12 by mod S11 square. Now, this implies, because neither of these quantities are 0, this implies this quantity must be 0. So, therefore, we say e to the power j theta 1 minus j phi that must be equal to 0. And from here I can say I can say and from here it is a simple exercise to say and then I can express this thing by a division. I can express this by division, and therefore, I can write e to the power minus e to the power 2 j phi, and therefore, I can from here write we can write 2 phi minus pi because of the minus sign, and from here I can write the phase of S12, the phase of S12, which is related to the phases of S11 and S22. So, we see that S12 is completely specified, it is a function of S11 and S22. It is completely specified in terms of S11 and S22. Okay. So, this simplifies the description of the circuit, because the magnitude and phases of S11, S22 can be easily measured. So, this completes this section. We will next continue with the next part. Thank you.